Good morning. Welcome to the module Amplitude Modulation. In this module, we will discuss about amplitude modulation, types of amplitude modulation, generation techniques, and detection techniques of amplitude modulation. So now let us discuss about amplitude modulation. As in the previous sessions, we have seen that types of modulations like amplitude modulation, frequency modulation, and phase modulation. So coming to principal definition of amplitude modulation, the amplitude of the carrier signal varies in accordance with the instantaneous value of amplitude of the modulating signal. First, let us verify the definition by the waveforms. Then we will verify or prove that by using equations also. So here we have our carrier signal and modulating signal in the definition. So I'm taking a modulating signal and carrier signal. If you observe here, at 0, here the amplitude is 1. So I can say that it is a cosine signal where cos 0 equals to 1. So I'm taking input signal as low frequency cosine signal and carrier signal high frequency carrier signal same cosine signal. The amplitude is represented with AM and time period T on x-axis. On y-axis amplitude is represented. Same thing with carrier signal. The amplitude of carrier signal is represented as AC on y-axis. On x-axis time period is represented. As I said, as low frequency signal. So here on x-axis we are representing the time period. So low frequency means it will take more time period so that the wave is like this. For one full cycle it is taking more time. Here on x-axis I am representing with time period so that the waveform will be like this. If it is high frequency signal, for less time period itself, it will give more cycles so that high frequency signal is represented like this. So this is input baseband signal. We can call it as message signal or information signal. This is the baseband signal. This is carrier signal. Now, coming to amplitude modulation waveform. This is amplitude modulation output waveform. If we observe the definition, on x-axis this is your amplitude. The amplitude of carrier signal, here inside it is a carrier signal. As we have seen, this is carrier signal. The same carrier signal is here. But what is the difference here? The amplitude is constant, right? But what happening here? The amplitude of that waveform is varied. It is varying. So if you see the definition, amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. So this is your modulating signal. Here if you join the peak amplitudes of this output, then you can observe the input waveform. It is looking like your input message signal. So here one of the characteristic is varying. What is that characteristic? Amplitude. How it is varying? It is varying with respect to input message signal. So if you see here, the definition is verified where the amplitude of this carrier signal, which we are showing here, is varied in accordance with the message signal. Why? Because if we join, we'll call this as peak amplitudes. If we join all the peak amplitudes of this output waveform, you can observe that as it is looking like input waveform. So by this output waveform, we can say that here the definition is satisfied. Then on x-axis here the amplitude is AC plus AM. Why? Because combination of carrier and misses. We will call the output of modulation process as modulated signal. We will call it as a modulated wave or signal. And we know that this is the maximum amplitude. We will consider this as minimum amplitude. Coming to equations representation. Here, this is carrier signal. As I said, cos 0 is 1. So, we are taking it as cosine signal. It is represented with C of t as the name indicates carrier. So, for easy analysis, we are representing it as C of t. C of t equals to AC cos omega C t. What is AC here? AC is the amplitude of carrier signal. Omega C is the frequency of the carrier signal, where angular frequency omega c that equals to 2 pi fc. This is the representation of carrier signal. Coming to the representation of message signal, where x of t equals to am cos omega mt. We are representing here with x of t equals to am cos omega mt, where am represents amplitude of the message signal or baseband signal. Omega m represents the frequency of the message signal or baseband signal. In the next session, we will see the proof of this one, that is modulated waveform equation of A. Thank you for listening.